Hey guys, welcome back to Rocket Gyan, my fellow space tubers. How are you all? I am so glad that uh, we have an Astra launch today because, as you know, they have been trying to launch, but due to various circumstances, they weren't able to launch. And as wise people always say, third time is the charm. So let's hope that is true and we get a beautiful liftoff today. So how are you all, guys? We have Jeremiah. How are you? Welcome to the stream. Iron Rope, welcome to the stream. John, uh, DJ Harrell, welcome to the stream. Hi, Dave. Let's hope this thing actually launches today and we get a great lift off today because I'm so hopeful. Now let's just have a quick look at the rocket company, and as you know what we do on this channel, you don't have to wait around and see what is what. So they will be launching first of all from Cape Canaveral, Florida, and right now weather is beautiful in Florida, so um, that is great. They used to launch from Alaska, as you can see, and they are very far apart. Those launch sites are very far apart, and there is a reason why it is because from Kodiak, Alaska, they can launch to polar orbits, and from Cape Canaveral, they can launch to the mid inclination orbits like today's one. And then they aim to go for 500 kilograms to 500 kilometers, but right now today the maximum payload capacity of the rocket is 50 kilograms. So let's since we have touched upon the rocket, so now let's talk about the rocket. Okay, so we have this thing here in front of you. So there you go. This is the Astra's Rocket 3.3, and if I can show you here, there you go. This is how it looks like. So there we have two stages in this, the first stage and the second stage. The second stage is inside the fairing, as you can see, enclosed inside the fairing. The first stage has these 5 Delphine engines running on RP1 and LOX as its fuel. So they are running on cryogenic fuel, as you can see. And the unique thing about this is that they run on electric pump fed cycle, which is also used by Electron rocket. So this electric pump fed cycle has its advantages, that it makes the rocket engine very simple, because there you don't have to do those, you can control everything by just the software, because the turbopump speed can be controlled by the software using the motor speed. And then gimbaling, also thrust vector control can also be done by actuators which are electrically controlled and not mechanically controlled. So everything, the rocket engine very much simplifies, and hence they use in these small sat launcher. Then we have this second stage. As you can see, is a skeletal stage, because they want to save on the weight, so they reduced as much possible. And this runs on first of all, this has an ether engine and runs on again RP1 and LOX, but this ether engine is just a pressure fed engine, which means they will just open up the valve and mix both the fuels with the igniter, and you are ready to go. So this is all about the rocket. Okay, so hi everyone. No, this is not an AI voice bill. You are hearing person out there. So if you have any questions or so, you can surely ask me in the chat, and hopefully I'll be able to answer them. So let's have a look at their payload. So the first payload which you will be seeing is from University of Alabama, is their Bama 1 payload, CubeSat, as you can say. And this CubeSat is very much unique because as I have repeated many a times, if you have joined before, that this CubeSat has its own advantages. This will is a technological demonstration satellite weighing 2.5 kilograms. Let me just show you how does it look like. So there you go. This is a 2.5 kilograms technological demonstration satellite. Upon release from the second stage, this Bama 1 satellite will deploy its 1 meter square drag sail made out of clear mylar to drastically, this is the drag sail they have, to drastically reduce the time to deorbit a CubeSat. This is specifically made for CubeSats because they don't have a propulsion system in place. CubeSats are really very small, just 2.5 kilograms, and size of a shoebox. So you can't have a dedicated space for the propulsion system. So there are certain things that you need so that you can reduce the time in deorbit after the reduce the time in orbit after its lifetime is accomplished. So um, what should I say, this usually takes around 5 years, but with the help of this drag sail, they will be the time would be reduced from 5 years to 2 to 3 months. So that is the significance of it, and this is how it looks like when it is packed onto the satellite. Biggest thing is that it can just go outside the satellite, and they don't have to it does not take any place inside the CubeSat, and hence those place inside the CubeSat can be dedicated for CubeSat instruments. And this is how it looks like once it is deployed. So you can see this is like literally a sail for a CubeSat, and low Earth orbit there is some sort of atmospheric drag, and it take that drag for its advantage to reduce the time to deorbit. So this is the first satellite we have. The second satellite is this one, coming from the INCA. This is known as INCA, the Ionospheric Neutron Content Analyzer. This is a 3U CubeSat. Again, this is used for detecting the neutron. This is basically a neutron detector in low Earth orbit, and this is first ever neutron detector in low Earth orbit. So this is a good thing to have, and this is how it looks like once the solar panel. This is like the launch configuration. This the solar panels are not deployed first of all. They are retracted like this, and the goal of this satellite is to gather data on the neutron spectrum in low Earth orbit first of all, and the second is to by gathering those neutron spectrum, it will be able to improve the space weather models. And right now this space weather model is very much in talks, because last week when the Starlink satellites were launched, around 49 were launched, and out of those 40 satellites have been killed because of a geomagnetic storm coming in from sun. So these kind of storms are very much are of very much significance. So it is very much necessary to study them so that we can reduce the chances of this thing happening. 49 out of 49 Starlink satellites, 40 were decommissioned because they were not able, the atmosphere expanded during the solar maxima, and those 40 satellites were not able to deploy properly and deorbited. So this is how it's look like. This satellite tends to, this is the first step to improve the space weather, and hence you can see it here. This is how it looks like once deployed, and yes, this is how it will look like in space. So this is another one of its kind satellite. I hope I'm making everything clear, right? Okay. So we have another one is this CubeSat. It is literally known as CubeSat, but the spelling is QUBESAT, and this is again from a university, but the aim of this satellite is to demonstrate quantum gyroscope, which is again a very cool concept, because the quantum gyroscope simply means that you are trying to make a gyroscope, but quantum using the properties of quantum mechanics, hence in an atom. So what it will do is it will use the nitrogen vacancy centers in diamonds. These nitrogen vacancy centers in diamonds are point defects where a carbon atom is substituted by a nitrogen atom with another neighboring carbon atom and missing in the structure of a diamond. This vacancy center has measurable quantum properties, which makes it possible to form a gyroscope that measures angular momentum. So that means this there is a diamond going on which will be flying to space here, and that diamond will have certain things like this in front of you, and yes, this is something new. So that I thought, let me just explain you this quantum gyroscope. So this is a quantum gyroscope. This is how it will look like. This is a slab of diamond here, you can see, and these are the RF coils which will be there. RF coils and microwave coplanar waveguides are fabricated on the diamond for fast control. The nuclear vacancy center are polarized by a green laser, as you can see here. And a second set of RF coils rotates with respect to the diamond chip frame, which is collected by using a technique known as side collection technique. So let me just tell you how the things look like. Okay, so this is a quantum gyroscope and this is a normal gyroscope. So here you will see some similarities, and that's how it is trying to make a gyroscope in quantum, using the properties of atoms, quantum mechanics. So here, as you can see, this is a green light coming in, and here you can see this is a spin axis, which is a hardware obviously. So this spin axis is here in the green light. So you can see this is a rotation axis. So this is by a polarizing light. Green light is a polarizing light which will act as a polarizer, which will polarize the atoms and change its state. Once the atom's state is changed, it will be this. So you can see there are this ring and this ring. So let me just tell you, first of all, this gyroscopic frame is here in this one. This yellow one is a gyroscopic frame. Okay, this thing is here, this RF coil. So what is actually happening is, once the states atoms are polarized, these RF coils are used to detect the change in the state, and by detecting those changes in the state, it will be able to detect the change in the angular momentum and hence the orientation. So I am hopeful that I am clear about everything. So this is the other satellite which is going in from NASA, and this is a technology demonstration mission which will have some certain prototypes of communications, super fast computers, which will be deployed. Once the technology is demonstrated, it will have a full scale development, and you will see those things happening in near future. So this is all about that. And today's mission is going to 41 degree inclination, 500 kilometer altitude. So I am hopeful that everything is clear now, and the weather is, probability of violating weather constraint is less than 10%. So that is great, and which means only concern is cumulus cloud rule, and hopefully that is not the case. That will not be the case today. So I am hopeful we will be getting a good enough view. Okay, let me see if we have that. Okay,
minus 57 minutes and counting. So ELaNa, let's start off with a status update. What are the teams working on as we proceed towards liftoff?
Sure, Thomas. As you can see, that middle third of the rocket is a nice frosty white as propellant load is ongoing onto the vehicle, and all things are looking nominal. And
a second, guys, I'm over to that. Give me.
You can see it's also a beautiful day in Cape Canaveral. We are not tracking any weather issues at this time, so we are going to proceed through our countdown with a T0 time in 56 minutes and 30 seconds.
The Space Launch Delta 45 and the 45th Weather Squadron predicted a greater than 90% chance of favorable weather today, and as you can see on your screen, that has definitely played out. Crystal clear skies, hoping for some amazing visuals from today's launch. Liftoff is also on track for the opening of today's window, which is 3 o'clock p.m. Eastern Time, which is again just about 56 minutes from now. And this mission is the first from Cape Canaveral for Astra. It's launching from Space Launch Complex 46, which is on the Cape Canaveral Space Force Station. On board this rocket are also the first satellites which Astra aims to deploy after a successful orbital launch. Those 4 payloads are part of NASA's ELaNa program, the Educational Launch of Nanosatellites program. The mission is designated ELaNa 41, also designated the VCLS Demo 2 mission for the Venture Class Launch Services program, which aims to provide dedicated launch services for small satellites like these CubeSats. 3 of the CubeSats are provided by different universities, the University of Alabama, Tuscaloosa, New Mexico State University, as well as California, Berkeley. And then the fourth payload is direct from the NASA Johnson Space Center. All 3 U-sized CubeSats on board. Those are the payloads on board Astra's first mission to deploy payloads into orbit, like I said. And as Carolina mentioned, no weather or technical issues right now. The countdown is proceeding. Over the course of the broadcast, we'll also keep you updated how that countdown is proceeding with any updates as needed. This mission does build off of the first successful orbital launch from Astra, which was the LV0007 test flight out of Kodiak Island, Alaska. And let's take a look at a quick recap, which shows how Astra got to today.
10,
Yep.
9,
Let's
8,
have a look at their first orbital launch.
6, 5, 4, 1, 0.
First motion.
First motion.
There was a study.
Vehicle is clear the tower.
But it's all right. Heading, second stage, fairing jettison and stage separation, and then the second stage ignition, and this was their first orbital flight. We are hopeful that you would see something similar to
MECO.
it.
And Astra's LV0007 has successfully reached orbit. There is a new orbital rocket. And we are now going to welcome a special guest to today's live coverage. Hemant Charazia is a Vice President of Product Management at Astra. Hemant, thank you so much for joining the live broadcast today.
Thanks so much, Thomas. It's great to be here.
So I want to talk to you a little bit about what you do at Astra and how you contribute to the team. So your role is Vice President of Product Management at Astra. What are your responsibilities in that role?
Yeah, great question. So I'm part of the product management team at Astra, and you've met Carolina Grossman, one of the stars of our team. Overall, the product management team is really all about answering the question of what is the right thing for Astra to build next. And that's based on understanding what the market is deeply, understanding what our customers need, and understanding what we can build. You can imagine that that's a very cross-functional activity, but fundamentally it's about charting that course forward and creating a few different things. One would be our North Star vision for the products that we're building, and the roadmap of releases that in step-by-step get us there towards that North Star vision.
You mentioned this being sort of a cross, a cross kind of capability where you have to work with other people. Do you work closely with the engineering and operations teams when you're developing these new products?
Yeah, absolutely. Engineering and operations are two very, very critical elements of the company to engage with in answering these questions, but also so many others. I think of program management, think of production, sales, mission management, finance, regulatory, spaceports. So many. There's a long list of internal and external stakeholders that every one of them has an important piece of the puzzle in understanding what is the right thing to build next that makes the most progress towards our vision for Astra.
Well, when aiming to grow your teams in order to pursue that Astra's kind of overall overarching goal as a company, what kind of skill sets and backgrounds are you looking for to join the product management team to achieve those goals?
Yeah, great question. And we're actually hiring very aggressively right now, looking to dramatically grow the product management team this year and as we expand the scope of what we're building at Astra. So your question is a good one. I think there are a few key skills that we really look for. I would highlight 4. The first one is customer obsession. We were really looking for people who are obsessed with understanding who the customers are and what their problems are and how we can help solve those problems, and then bring those insights to the rest of the team as part of our product development process. Second thing I would highlight is it's important to have a combination of technical fluency and business thinking. So product managers in this process, as you can tell, are really a bridge between the business side of Astra and the technical side of Astra. And so it's important to be able to work and speak equally well with both. Third one is ability to learn fast. You can see on the pad today, our launch system, our most celebrated product at Astra, is really the first of its kind. There are no other container shippable rockets, and what we're doing is a first in so many different ways. So everybody in the product team really has to be able to learn fast about new technologies, new markets, new types of businesses. And then the last thing I would say is ability to bring people together, ability to convene, to influence, to really align a broad cross-functional team around a vision for the product, a thing we're trying to do in the world, and then to ship that, to work together to bring that into reality. And so these 4 key skills are intrinsics we look for, and we have great people in our team right now. In terms of backgrounds, I would say that product managers in aerospace are a bit of a rare breed. It's not really a traditional role. So there isn't any cookie cutter formula for background. Certainly, people who have had product management experience at other companies that build mixed hardware and software products, they will have had an opportunity to build many of these intrinsic skills we're talking about. So that's a great background. But also, it doesn't have to be that. And also, it doesn't have to be any particular industry. At Astra today, we already have a very diverse range of backgrounds at Astra. People have come from automotive, from big tech, from aerospace, from all sorts of different industries, and we hugely value that. It's really an important part of the magic at Astra about building something that's fundamentally different as a new future for the space industry.
That's great to hear.
And so
you
that team,
are
which comes
willing,
from all of those different
you
diverse
can go.
backgrounds and experiences, is all coming into Astra to achieve Astra's or aim towards Astra's long-term goal of improving life on Earth and from space. How does today's mission, the LV0008 mission, and your work in the product management team work towards achieving that goal?
Yeah, great question. And I love this question. It can never be asked too many times. I think big picture, a really important step in improving life on Earth from space is to develop the scientific understanding and the scalable technologies that we'll need to build something really useful in space, the next generation of space-based services. That's really what I see as the theme of today's mission in a few different ways. And the 4 satellites that we're launching today from 3 awesome university teams and NASA's Johnson Space Center. The way I look at it, the 4 satellites we're launching today advance 2 broad goals. The first one is to help scale up our use of space, and the second is to do that more sustainably. So on the first theme, this scaling up, the first one I'll highlight is the R5S1 mission from NASA Johnson Space Center. They're really demonstrating a faster and cheaper way to build CubeSats, and simultaneously testing out new ways to get better data on how satellites are operating on orbit. This is very useful diagnostic information for scaling things up. The second payload that fits in this sort of theme of scaling up is the CubeSat mission with a Q from the University of California, Berkeley. And they're testing out a new kind of quantum gyroscope. A gyroscope is a critical element of every satellite on orbit that helps the satellite understand where it's pointed and where it is. And making these this quantum gyroscope is one potential path to smaller, lighter, and cheaper gyroscopes. That's another way to scale things up in space. Overall, these 2 give us new ways to make cheaper and more scaled satellites. On that second theme, though, on sustainability, I would say that the first one, the BAMA-1 mission from the University of Alabama, Tuscaloosa, will test a new drag sail, which is a bit like, you can think of it like a parachute in space. Now, to really improve life on Earth from space, we need to be able to safely operate thousands of satellites in low Earth orbit. And an important part of that is to be able to very reliably bring satellites down when they've either failed or otherwise reached the end of their life. A drag sail is one promising solution to that problem, part of the suite of solutions. And the BAMA-1 mission is taking a really important next step in the development of this technology. The final payload I'll highlight is the Inca mission from the New Mexico State University Las Cruces. They're using a neutron spectrometer to take a new kind of measurement of space weather, to better understand space weather and predict it. Now, maybe many people in our audience don't think about space weather every day. What this really is to recognize that our sun is a dynamic and powerful force that's constantly emitting a stream of high-energy particles towards the Earth. And that bombardment of the Earth creates a space version of weather that satellites need to fly through and operate in. turns out that it's really important for satellites to account for this and for us to understand what they need to be designed for in terms of space weather. Just this week, for example, in the news, we saw a large number of satellites lost on orbit purely due to the impact of space weather. So what the Inca mission is doing is really on an important topic to understand and better predict space weather. I'd say as sort of a backdrop to all of this, there's something a bit here for Astra, which is the launch today is Astra's next step in expanding access to space. Why do we care about that? Well, this is exciting for us because easier access to space means more great student teams and researchers flight testing new technologies on orbit. It means more entrepreneurs building valuable space services on orbit. And it means more governments and institutions building systems that benefit everybody in the world from space. And I think from my own days as a student at MIT, I've seen firsthand how awesome the innovations can be driven by a team of students and researchers at a university lab. And but historically, it hasn't been very easy to get those things into space, to flight test them. And so that's why, for me, it's such a huge honor today to be watching us give an opportunity to fly payloads in space from these great student and researcher teams. And so I'm very excited to see them fly and to see Astra take its next step in expanding access to space.
Absolutely. Heyman, thank you so much for joining us. I've loved hearing all that insight into both today's mission and your role in the product management team. So thank you so much for taking some questions with us and hanging out.
Thanks so much, Thomas.
All right, let's go ahead and listen into activity on the countdown net as the countdown proceeds at T-minus 43 minutes and counting.
Okay, so guys, we are, as you heard, if you are willing to, if you are based in US and willing to work in a startup, that to a rocket launch startup, there's a great opportunity right now. Astra is hiring, so you can go there. And as of today's mission, right now everything is looking good. As you can see, the weather is so good today. We have seen the weather previously in two attempts, and it was not great. Cloudiness was there, and today the weather looks so clear. So let's hope we will be getting some good views, and hopefully this thing actually launches today. So this is an Astra Rocket launch. The rocket which you are seeing on your screen is a rocket 3.3.
Tango and AV1 manage polling. Please toggle do both ground and guidance polling mode.
Toggling do both ground and guidance polling.
Okay. Yeah, so I was saying,
Tango, I'd like you to re-enable pump battery charging by going into machine, pump battery 2, manage pump batteries, and setting mode 3, reset machine.
Toggling 3, reset machine.
okay, so actually they are right
And
now
then
just
mode 1, charge pump batteries.
starting up the rocket, as they say. They are doing going through the checklist. So let me let me just finish. This is the rocket 3.3. This is a two-stage rocket. The first stage is powered by 5 Delphin engines, and the frost which you are seeing is because of liquid oxygen it is carrying, and the second fuel is the kerosene. I remember this is not exactly RP1, but it is similar to that. So yeah.
So we just listened in on some countdown steps being proceeded. Again, everything on track right now. We're at just under 42 minutes and counting for today's launch. Again, targeted for 3 o'clock p.m. Eastern Time. Like we said, we want to take some questions from chat over the course of today's broadcast. So again, if you've got questions, tag us with @NASA Spaceflight, and we're going to be bringing a couple of those in, and we got a few of them here now. Keith is asking about the last launch that Astra conducted, the LV0007 mission. What was the goal and achieved objectives of that mission, Carolina?
Yes, so the LV0007 launch in November, we saw the video of it just a few minutes ago if you joined us at the beginning of the broadcast. That was our attempt to reach orbit. We have constantly been working towards that milestone, and LV0007 successfully reached orbit with a test payload on board. And so that test payload on board LV0007 was not deployed. So today's mission, LV0008, represents a few firsts, one of them being that this is the first Astra mission with payloads that we will deploy into space, as you just heard a lot about these exciting CubeSats and the scientific investigations that they will conduct. And it's also our first launch out of Cape Canaveral, so it's a couple of historic firsts for for Astra with today's launch, and we are very excited to see how it goes.
And a related question, Arda is asking if Astra can launch payloads into polar or retrograde orbits, and I believe that ties in directly with the launch site that's being used for any particular mission, right?
Right. So if you have been following us for a while, we have launched our previous rockets out of Kodiak, Alaska, the Pacific Spaceport Complex, Alaska, and that location, which is a very high latitude, is great for reaching high inclination orbits, including polar and SSO. So yes, we can reach polar orbits, and technically those retrograde would be flying, launching against the direction of Earth's rotation. So there's nothing really to prevent us from doing that either. But we're focused on the objectives that our customers want to achieve, and a lot of that is driven by our launch location. So while our Kodiak launch site has been great at helping us reach high inclination orbits, this launch site in Cape Canaveral is really wonderful for reaching mid-inclination orbits, which are particularly important for things like communication and weather observation, where you can get more coverage over the middle portion of the globe.
Another launch site question here from Matt. Could Rocket 3 launch from a boat at sea?
That's a very interesting question. I'll talk a little bit more about our approach to our launch infrastructure. So everything that you see in front of you here can be shipped inside a shipping container. And so no launches at sea at this time, but it does make it very easy for us to set up and deploy a launch site. And even the rocket itself is 43 feet from tip to tail, so that fits inside a 45-foot shipping container, a bit snugly, but it is one of the key differences about Astra, where we can ship everything to the launch site, and really all we need when we get there is a concrete pad, an internet connection, and a fence to help keep the area safe.
Great.
And we have another question in chat asking about, again, kind of related to launch sites. A lot of launch site questions, which is good, because first launch from Cape Canaveral, it's on topic. Does each vehicle get built slightly differently according to where it's going to end up eventually launch from?
That's a great question. And no, that is one of the things that helps us on our path to scale and we improve life on Earth by improving access to launch. So the rockets are built as identically as possible. We may make small tweaks in between, because our objective is always to learn and improve our system. However, those at this point, those have been pretty minor, especially given the success of the LV0007 launch back in November. So we do make the rockets identical. It doesn't matter where they are launching from. They are exactly the same. The only differences may be any changes in our communication systems to ensure compatibility with the specific range, and any special payload adapters that we need for that specific mission. Otherwise, it's the same rocket regardless of where we are launching from.
Great.
And looking at the launch site a little more closely here, we have a question that we should have known we were going to have, although this is an interesting interpretation of this question. What are the pylons that look like they'd attract lightning for? Well, you pretty much got halfway there. Actually, on this particular camera view, on the very left-hand side, you can see the bottom part of one of the lightning protection towers, and they are there, like you said, to attract lightning. It helps protect the rocket. Space Launch Complex 46 has two big prominent lightning towers seen here as well to help protect the rocket. But of course, this pad is actually built for rockets. It's one of the smaller pads at Cape Canaveral, but still built for rockets that were traditionally bigger than Rocket 3. So Rocket 3 is just barely poking up over the trees in this view. Even this pad makes Astra's rocket look small, because it's dedicated to those small satellites.
Cool.
Another question here, Paul asks, is what makes Astra different from its competitors? What strengths do they have that other providers maybe don't have?
That is a wonderful question. And Astra, our mission is to improve life on Earth from space, and the way that we're hoping to do that is by developing the most responsive and affordable orbital launch system. So in terms of responsiveness, what we were just talking about with our ground support equipment, fitting in shipping containers, being easily able to set up and tear down a launch site in a matter of weeks or days. That's one of our key advantages. And the reason that that's important, as we mentioned, is that a lot of the orbital destinations that you can reach depend on where you can launch from. So being able to be mobile and agile helps us to provide customers with access to the locations they want. The system is also really set up by a very small team of folks on the ground and operated by a small team of mission control and support engineers in our facility, which allows us to be really nimble. And it's also been really helpful during the COVID-19 pandemic, where it's allowed us to remain as safe as possible and minimize our travel. And finally, on the affordability front, we take pride in using low-cost materials and trying to lower the cost of access to space with our vehicle. And I believe that Thomas, you had a tour with our facility with our head of production, and that's been an exciting thing to learn a little bit more about how we go through the steps to make our system as affordable and low cost as possible, including staying away from fancy materials like carbon fiber and composites, and using as much automation as we can across our system.
That's
Yeah,
cool.
Caroline, you set me
And
up.
speaking about these cost, so this Astra launch vehicle actually is a very cheaper way. It right now the cost per launch for Astra vehicle is around $2.5 million per launch. So it's the cheapest one to have operational in the present, because Electron also is $6 to $7 million. So right now the operational rocket, which is the cheapest one, is the $2.5 million. Is this Astra's Rocket 3.3.
And simplifying the manufacturing, the different materials you choose, those are the kind of factors you're looking at to reduce launch prices, right?
Yes, exactly. That's right. We take a number of steps in order to make our system as cost effective as we possibly can, and hopefully our customers can take advantage of that and get more payloads to orbit.
And
That's
speaking of getting those payloads to orbit, we have a question from Redacted. I don't know if that's their actual name or if I just am not allowed to know the name, but we'll go with it. The question is, what's today's trajectory? Is it flying direct east or somewhere else? I believe we even have a graphic to show where the rocket will be headed, and there it is, right on cue.
Yes, so this is the trajectory that the rocket will follow. We'll be following sort of that middle area. Those blue lines are the NOTMARs, the notices to mariners, the area that boats will keep away from, and then the red area is sort of our safe area that we have cleared with the FAA. So after the rocket clears this trajectory, we'll be flying. Starting to swing around towards the south again, flying over Portugal, Spain, the Sahara Desert, Ethiopia. So we'll be hoping for a nominal trajectory as we launch out of Cape Canaveral.
That's great.
And if you are down here in...
Hi, Casper, welcome to the stream. So how many launches are on the planning for coming months? Astra is right now planning for multiple launches. The other launch is scheduled for Feb 20th only. Another launch is also there. So I don't know whether they will be able to launch this month or not, but they have another one scheduled for today. So that must have answered your question. They are trying to launch frequently. Last year they only launched one rocket, and now they are trying to launch 2 rockets in the same month. So we'll see how frequently they will be able to launch, because as they will launch more, they will gain more data, they will improve the systems, and by improving the systems they will be able to launch more frequently. So yep.
If you are not local here to the Space Coast, we are, of course, thank you for tuning into the webcast. Happy to provide you with the views of the launch of this way. And we have a question from Sean who asks, or excuse me, I'm reading the wrong thing. Different question from K2K81. I don't know what that means, but thank you for your question. Are there any cameras on board the rocket? And if Michael gets that cue, he's going to show one of those cameras. There we go. Carolina, what are we looking at on these
The
views?
second
Sure.
stage
So you are
camera.
looking at the upper stage of LV0008. So that the sort of top right-hand side of your screen, that is the fairing, and we will hopefully see very shortly after main engine cutoff, we will have stage separation and fairing separation, and those fairings will pop open and we'll have a beautiful view of Earth as the upper stage ignites to complete the final leg of the mission. And then this is a view looking upwards at our payloads. So we'll be tracking them as they deploy after SECO or second engine cutoff.
Love seeing those onboard views. We're hoping to keep those throughout the course of the broadcast and show those as much as we can. We've also got these ground cameras, of course, and with perfect visibility, hopefully we'll get some good views from them as well. I do have a question from Planetary Space, which is talking about the most recent abort and scrub. If you tuned in earlier, this is not the first launch attempt, like we said. This is the third attempt for this particular mission. And
Yes,
last time there was
updates
that
would be
scrub due
nice.
to that telemetry issue that the teams had to stand down to resolve prior to coming back today. But we saw that abort happen right at engine ignition. So the question is, what do the teams have to kind of work through when you light a rocket engine and then scrub? Could the engine be damaged from an abort like that, or other systems that have to be inspected and things?
Sure. So first, to speak a little bit about the abort that happened on Monday, our team conducted a data review after our engines lit, and we learned that the abort was due to the rocket detecting latency in our internal telemetry communication, and it was a bit longer than we typically experience. We determined that it was unlikely to have impacted flight, but felt that it needed further review. And after this review, the team was able to identify the probable cause and potential effects and run some simulations to determine that an impact to flight was unlikely, and also test some adjustments to improve the latency of the system in preparation for our launch attempt today. So we believe we have solved that issue. And now, more directly to the question, our system is actually designed for multiple ignition events. So we complete a static fire of the vehicle. It's our last major test of the full system. Essentially, we run through our entire countdown procedure, load propellants, light the engines, and run them for a few seconds, and essentially do everything except actually release the rocket. So we do design the system to be able to complete multiple ignition attempts, multiple launch attempts without damage or issue.
Exactly, as
Excellent.
I said in
We're actually
my
hearing that
previous
teams are
stream
getting it.
also, that the igniter which is required for
27 minutes and counting.
okay. So yes, as I was saying, the igniter, as she said, this is capable of reigniting, but the reignition can only happen during the ground, and it is on the ground. So why it can happen? Because the igniter fluid, or you can say the igniter only, is supplied from the ground. So that igniter is not loaded onto the rocket, but is supplied from the ground. So if there is a issue during the launch, then they can replenish that igniter fluid by supplying it from the ground. So that's why they have the capability. Also, this is one of the reason. The other reasons are the smooth good, I could say, good clearance of the pipelines once if it has any sort of abort or something like that, because if there is any clogging or some sort of like that, it won't be able to reignite. So that is a good system design which they have made possible. So right now we are T minus 26 minutes 40 seconds from the launch. Everything is looking good. We are waiting for this thing to launch, and hopefully this time it will launch, and we would see some beautiful, magnificent views when it will go up into the sky and beyond. And guys, if you are just tuning in, we are waiting for this to launch, and everything is looking good. And give this stream a like, and please hit that subscribe button. It would really help me, and consider becoming a member. These type of streams wherein I explain each and every part of that launch is kind of very hard to make. So if you can support me, it would be great, and it would help keep this channel alive. So yeah, we are getting good on that launch time. So what else do we have in here? And guys, talking about the investors here, let me just tell you guys, please, I know what has happened previously, but don't do that. If there is a bot or a scrub, please don't sell your stocks, because it will be a problem. In rocket industry, a bot is nothing. A bot is nothing. So wait for it to be successful today and your stocks will rise.
So we'll keep some questions coming, and the liftoff is still targeted for the opening of the window at 3 o'clock p.m. Eastern. This question from Sean for ELaNa: how big is the launch window today, should any issues have to come up?
Right, that's a great question. We have a 1-hour launch window today. So our launch window extends from 12 p.m. Pacific 1 to 1 p.m. Pacific. I am blanking on my UTC math at the moment, but we do have a 60-minute launch window. If we encounter an abort or an issue, our recycle time is typically around 15 minutes once that issue is resolved, so there is a possibility that we would be able to try again in the event of an abort. But again, everything looks nominal at the moment, so we are not anticipating any issues at this time.
If I use the time you took to answer that question to do some math in my head, I think that translates to 2000 UTC to 2100 UTC for those of us watching, or those of you watching from across the globe. Thanks for tuning in, and that is our launch window for today. I have another question here from Santosh, who asks, what engine does the rocket use? And I'll just expand that really quick, because I believe we have a cool view of all the different components of this rocket. ELaNa, want to run us through what makes up a Rocket 3 from Astra?
Sure. So on the left side of your screen, you can see the expanded view of our rocket. We'll start from the left. That is the engine bay. You can see 3 out of our 5 first stage engines, the Delphin engines. They are electric pump-fed engines, each producing a thrust of 6,500 pounds for a total of 32,500 pounds of thrust on the first stage. The next large section is the first stage tanks. And those are filled with LOX and kerosene, liquid oxygen and kerosene, which are our propellants for both stages of the vehicle. The next section is our inner stage, which houses the large portion of the upper stage and our avionics system. Then further right, we have those 2 spherical tanks and the smaller engine with the long nozzle extension. That is our upper stage. Again, the upper stage is filled with LOX and kerosene, just like the first stage, and we have 1 pressure-fed ether engine, which produces 740 pounds of thrust. And then finally, you see those 2 split halves of the fairing. And on top, we have of the upper stage, you can see an example of a CubeSat payload. Again, today it represents Astra's first mission deploying customer payloads into orbit, so we will be keeping an eye for that fairing separation and the payload deployment at the end of our mission.
Awesome. Great. So we have, do you think it's a mistake for Astra to not develop reusability for their first stage? I'll answer that.
To the countdown here. The current time is T-minus 22 minutes and counting, and all systems are nominal. Let's listen in to the activity on the countdown net as the teams continue to prepare for liftoff in just under 22 minutes.
Okay, so talking about the reusability factor, see, this is reusability is actually there to bring down the cost, and if you can reusability is the easy way. Obviously you have to develop the tech and everything, but if you can just recover the first stage or recover the hardware, that is always an easy way. But optimization of the hardware, that is the harder way. So Astra has gone for the optimization, because right now they didn't have any other path, because obviously this rocket is a small set launcher, and if they had developed it keeping reusability in mind, it would mean that they would have to make larger rockets, larger engines and larger everything. to accommodate that payload penalty. So what they did, which is a smarter and the only thing to do, is to optimize the already available things, optimize those things so that they consume less fuel, optimize those things so that they are made in a way that is cost effective. Okay, so this is how they are trying to answer that question of reusability. They are not reusing the hardware, but they are trying to optimize the already available hardware so that the cost is down. So and that is evident from the fact that their cost per launch is just $2.5 million as compared to other rocket launches, which is the cheapest right now. So yep.
Toggling spark now.
Andy says, welcome to the stream, Andy. How is the wind speed right now? Wind speed are in bounds. I don't know what is the actual count, but it is in bounds, so we shouldn't be having any issues on that. Okay, so yeah, so everything is looking good right now. We are T minus 19 minutes until the launch. Everything is looking nominal, and please guys, just wait, and you should be seeing a beautiful launch today. I have seen the Astra launch before also, and they are always exciting to see, and we are hoping to see something similar today also. And
please confirm results of spark test.
yeah, waiting for the spark test.
Dolphin confirms good spark.
There you
Copy,
go.
thank you.
A good spark test, which means good spark test means a spark plug kind of a thing for igniting the rocket engines.
Countdown steps are proceeding nominally. We're under just about to cross T minus 19 minutes and counting. Everything going well so far. What you were listening there was the mission control teams in Alameda, California, working through those countdown steps. And ELaNa, can you walk us through who those team members are and their various responsibilities today?
Sure. So we just have this graphic that has popped up with their names. We'll start from the top left today. So we have Rose Jornalis, who's our flight safety.
This is the view of the mission control, as you can see, and they are the people responsible. And you can see actually they are very stylish also, with googly eyes and that hairstyle, you know. So this you know, those these companies which are actually a startup have a very good culture, and this is evident here also.
Is our vehicle controller, who with the call sign of Tango, and she is the one who is doing the steps to load the software on the vehicle. She's the one who is the operator of our launch system. Chris May is our command and data handling, or CDH, and he's responsible for monitoring and adjusting any of our state machines.
Guys, please hit that like button and subscribe for more awesome live streams. We will be having some interesting launch streams happening this month, and I'll be providing that to you with everything that you need to know. So hit that subscribe button and please help me grow this channel by becoming a member or a Patreon. Link is down in the description. That would be great. So Sanju asks, revenue wise, what this launch can generate for Astra? Is this one better, or the next launch is better in month revenue wise? See, there is no as such thing called as month revenue in rocket industry. I would say that as they launch frequently and more, they would improve their systems, and they would bring down the cost. So as they start launching more and more, they will bring down the cost, which will increase their profit. So that's, I hope that will answer your question. So with each and every launch, they will be getting more profit, I must say, and then there will be a constant line after some few launches. So yeah.
They're the ones who set up the launch site, do any work required to configure the vehicle and the ground support equipment for flight. We are very grateful for them and hope they're enjoying the beautiful Florida weather, which is much nicer than it would be in Kodiak this time of year. We have Ryan Hirschfeld, our safety officer. Adam Frisch is our red lead. Robert Freeman Eric Larson, Sam Hirschap, Benjamin Whelan, Rusty Haller are our red team. And then we also have, in addition to...
Hi, John, welcome to the stream. In the UK, we say third time is lucky. Yes, I hope this third time is the charm for Astra also, and we all hope that. And it we are T minus 50 minutes 49 seconds, so it will take around 45 seconds or so to enter the terminal countdown, and we would see how the things would proceed after that.
For sure. Right now, 15.5 minutes to go. Again, everything on track so far. At the T-minus 15-minute mark, there will be the entering of terminal count. And that is going to be a big milestone. There'll be some other steps right after that as the teams get into that terminal count, followed by a go, no-go poll just over 10 minutes to go in the countdown. So let's go ahead, listen into the countdown net. We should have a water test incoming and then entering terminal count.
We'll have to see whether they will be we will be getting a water testing or not, because they when they have good systems, you know, for water, they don't do the test. We'll have to wait and see. And right now it has entered the T-minus 15 terminal countdown, which means everything is looking good, and from now onwards they are checking all the critical systems for the rocket, and hopefully we would be seeing a good enough countdown.
Self-test. GNC call out upon completion.
Running GNC self-test.
We'll go.
You should be seeing the water test, I guess. GNC self-test is okay. GNC guidance and navigation control. That's not. I support. I thought they are saying GSE, ground support equipment. That is not the case. So we'll still have to wait. Yes, guys, please hit that like button and let people know that something great is happening today. We are having a cool rocket launch, and we are just T-minus 14 minutes away from it. Again repeating, guys, this is the first time. Okay, GNC self-test passed.
Confirm that FTS is still enabled and nominal in the vehicle.
Safety can confirm.
Tango.
Yes, that's great to hear. So yeah, I was saying this is the first time Astra is launching from Cape Canaveral, and people who are near to Florida, they will be seeing a good launch today.
Sure. Well, before liftoff, just a few seconds before, the 5 first stage Dolphin engines will light, and at T0, if all of the checks pass, we will have liftoff. The hold down mechanisms will release the vehicle, and we will be at the beginning of our journey. Just a few seconds in, we'll begin our pitch over maneuver and expect to reach MaxQ at around 1 minute and 10 seconds. That's the point of maximum aerodynamic stress on the vehicle, and a significant milestone to hit in first stage flight. Then a few things happen in pretty quick succession. At 2 minutes and 50 seconds, we'll have main engine cutoff, or MECO, then fairing separation and stage separation, right before the upper stage ether engine ignites at 3 minutes and 5 seconds. The ether engine will burn for about 5.5 minutes before second engine cutoff, or SECO, at 8 minutes and 30 seconds. And then at 8 minutes and 40 seconds, we will begin our payload deployment of our 4 CubeSats, which will be deployed within a few seconds of one another, and we are hoping to get a good view of from our onboard cameras. And if we have completed all of those steps, we will have achieved mission success, and we'll consider today a very good day.
Great to hear. And Jenna says, watching from Vero Beach.
Right,
I am so jealous of you right now.
We're coming up on that go, no-go poll.
Okay, let's listen into the no-go, no-go
team
poll.
for their readiness for launch, and hopefully we'll get a go condition to proceed with launch in just over 11 minutes. So let's listen in.
Everything is looking good as of now, and go, no-go poll
Toggling
will
off chill. Toggling off
confirm
load
that.
first. Toggling off load upper. Deactivating aux4 operate.
Deactivate aux1 OV201 first fill.
Deactivating aux1 OV201 first fill.
aux1 OV401 fill.
Deactivating aux1 OV401 fill.
So now they are actually deactivating the fuel lines, for the upper stage and the first stage. So you are hearing that.
Please toggle off first and full.
Toggling off first. Toggling off full.
Please deactivate fuel 4 operate.
Deactivating fuel 4 operate.
Deactivate fuel 3 supply.
Deactivating fuel 3 supply.
Fuel 1 FV300 upper fill.
Deactivating fuel 1 FV300.
Yes. So don't get scared by the word deactivating. That's just they are deactivating the fuel lines.
Deactivating fuel 1 FV200 first fill.
Deactivate AV1 radios
Deactivating AV1 radios.
and AV1 rocket support cart.
Deactivating AV1 rocket support cart.
Please confirm zero stop purging is still enabled.
Confirmed.
AV1 manage polling.
Confirmed.
AV1 manage power systems.
Confirmed.
The helium stack.
Confirmed.
Please activate igniter 1 spark test.
Activating igniter 1 spark
So
test.
guys, everything is looking good. We are T minus 10 minutes and we are actually seeing a launch, and I am very much hopeful today. I have high hopes today and high expectations also, that and gut feeling too, that this will be launching today and we will be having a successful liftoff as well as a successful launch of all the satellites. So waiting in for the final poll, guys. I'm so excited right now. T minus 9 minutes. Finally, it is happening without
With
a
launch
hitch.
activated, please toggle locks topping.
Toggling on locks topping.
Okay, team, this brings us step 151. Poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. That is a hold, hold, hold over the net. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Dolphin.
Dolphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Safety.
Safety is go.
Flight is go. Tango and AV1 manage polling.
Let's
Please toggle do only
go.
ground.
We have
Toggling do
a
only ground
successful we have a go for the launch today, guys, and we are actually will be seeing this Astra Rocket 3.3 going up to the sky, and hopefully it won't perform that X maneuver, crazy X maneuver. This small rocket is actually very naughty when it comes to launch, so let's hope this thing launches and we get a beautiful launch. Yes, we are go for the launch. Ryan says, what's the mission? Mission is to deploy 4 satellites to low Earth orbit at 41-degree inclination and 500-kilometer altitude. And those 4 satellites are the CubeSats. This is the first time Astra is launching from Cape Canaveral, and this is the first time they will be deploying the payloads too. So this is an exciting and a good milestone for Astra. So T minus 7 minutes and counting. The thing is go, and I am so excited.
Loading sequence 863 Victor 1 on engine Delta. Good load.
Engine Echo 864 Victor 1.
Loading sequence 864 Victor 1 on engine Echo. Good load.
Ether, what can we load for you?
Ether sequence today, 842 Victor 3, please.
Loading sequence 84.
Right now what you are hearing is the actual software being loaded to the or you can say not the software but the configuration being loaded to these rocket for the engines as well as for the engines.
You just heard the teams have pulled go for launch and are into the final steps before liftoff. Carolina, this mission is about to lift off. What is the purpose of this mission? One more for people who are just joining us.
If you are just joining us, Astra is looking to deploy 4 CubeSats on this mission. Bama 1 from the University of Alabama, Tuscaloosa, demonstrating a drag sail module that will rapidly deorbit the satellite. Inca, ionospheric neutron content analyzer from New Mexico State University, Las Cruces, which is a scientific investigation mission studying the neutron spectrum in low Earth orbit for the first time. CubeSat from University of California, Berkeley, a technology demonstration to test and characterize the effect of space condition on quantum gyroscopes using nitrogen vacancy centers in diamond. And R5S1 from NASA's Johnson Space Center, Houston, demonstrating a fast and cost-effective way to build successful CubeSats. These are being launched on the ELaNa 41 mission, which is selected through NASA's CubeSat launch initiative and provided under a Venture Class Launch Services Demonstration 2 contract, which provides dedicated launch capabilities for smaller launch payloads awarded by NASA's Launch Services Program. So we are very thankful to our partners at NASA for providing us the opportunity to complete this mission for our 4 CubeSat payloads.
No, Marlon, that won't happen
Coming
today.
up on T-minus
Don't
5
worry.
minutes and counting, we're going to go ahead and listen
Okay,
back
this
into
is
the
happening.
teams as they work through the final minutes of this countdown. And we'll be looking forward to a liftoff. Again, liftoff targeted for 3 o'clock p.m. Eastern Time, which is just under 5 minutes from now, and everything on track so far.
And now they have topped off the fuel tanks, cleared the fuel lines, and you are seeing less activity on those vents because the vents are closed for it to be pressurized for the launch. And we are T-minus 4 minutes 30 seconds to the launch. Everything is great, weather is looking excellent, range is holding up, no issues on the rocket, and we are hoping for a successful liftoff. There you can see
Will be an immediate abort regardless of source.
You can see the crew at our Astra headquarters gathering to watch the launch.
T-minus 4 minutes and counting. Some good activity
Jealous of
near
Thomas,
the
who will be
rocket.
stepping away from his desk for a moment and hopefully watching our launch in person.
Just Jason, just look up to the sky right now. All the people who are trying to watch this launch, please, there will be some delay also for this stream, so just go out and look out at those rocket launches sites.
Hoping for a nice view of LV 0006. Excuse me, LV 0008.
No, Carolina, LV 0006 performed that crazy X maneuver, so let's hope that does not happen today.
This is flight on countdown. Please confirm range is recording telemetry at this time.
Confirmed.
Range is holding up, guys. You heard the
Require RF data in flight. Be prepared to switch over your pages. MIFCO flight on
T-minus
countdown.
3 minutes.
MIFCO, prepare to issue option when rocket IIP marker passes MECO point and is within dispersed trajectories, calling out at event.
MIFCO copies.
Thanks for tuning in, Marlon, and all the people. Let's hope this thing launches and is successful. T-minus 2 minutes 40 seconds. I'm getting very excited right now. On launch already.
Two minutes and 30 seconds until T0 of the ELaNa 41 mission.
Again, repeating, this rocket is going to 500 kilometers at 41-degree inclination, deploying 4 satellites to low Earth orbit.
FTS this time, send master enable and watchdog on AFTU.
Guys, hit that like button right now
2 minutes.
and enjoy the stream. T-minus 2 minutes remaining. All systems holding up. Yes, Gaurav, let's go. Hit that like button and share it with your friends. Just 1 minute
Copy.
remaining.
Thank you.
Again, repeating, guys, on this
90
channel,
seconds.
we do the live streams of all the rocket launches like this with everything you need to know. So consider subscribing for upcoming launches. T minus 1 minute 20 seconds. This is happening now.
Ace at this time, start PSD recordings and downrange ground station recordings.
Good work.
T minus 60 seconds, guys.
60 seconds, vehicles on internal power.
So he's on internal power.
PSD recordings enabled.
45, first stage coming up to liftoff pressures. Tanks are pressurized at this time.
T minus 30 seconds. Okay, guys, sit back and relax and enjoy the launch. Minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10,
9, 8, 7, 6, 5, 4, 3, 2, 0.
Whoa. See that dude go.
LV0008 has launched and is on its way to
This is looking
space.
so cool.
You can follow the flight milestones on the left side of your screen, as well as the velocity and altitude of the vehicle. Our next
Wow.
objective is MaxQ.
Let's hope they will manage to get into the orbit now. Next objective is MaxQ, the maximum aerodynamic pressure. Right now, things are looking great. Velocity is 45 meters per second. Altitude is already 2 kilometers. And if this rocket passes MaxQ, that would mean this is structurally holding up. Okay. Everything is looking nominal from here. Although we are not getting some mission call-outs, but everything is looking nominal here basically. So MaxQ coming up shortly, 373 meters per second, 14 kilometers. The velocity is increasing rapidly, and this is nominal, guys. These are contrails that happens because of the environmental conditions, so nothing to worry about. Everything is looking as we
Should have passed through MaxQ. All systems on the vehicle are nominal, and we are tracking it downrange.
We should be getting some onboard camera views shortly. We
We'll
are
be looking
expecting
for
that.
MECO or main engine cutoff at T plus 2 minutes and 50 seconds.
So we could get those onboard cameras working shortly. MECO is the next step. Everything is holding up as we want.
Clear skies have provided a great view of LV0008 so far.
50 kilometers altitude, 0.9 kilometers a second. MECO coming up. We were expecting some onboard camera views, but hopefully we would get to see those in the second stage. Let's see. Right now, everything is going as per the plan, and I hope
Flight,
that's
MECO, option sent.
Copy.
FTS confirms option detected.
Safety can't confirm.
That call out of the option means that the system will safely be able to ignite the upper stage after
MECO.
our stage separation.
MECO
And that was
confirmed.
MECO or main engine cutoff.
Oh, whoa.
That was fairing separation and stage separation. And you can see that the upper stage ether
is
That
engine
is
has
not
lit.
looking good, guys. Not looking good. And there is, oh man.
Opening FB 200A, opening FV 300A.
That was not supposed to happen, and you heard the mission control just after the cheer.
Opening OV 202.
I think it's F's in the chat, guys. F's in the chat. F's in the chat. And don't worry, guys, we would do some initial let's hope not a failure right now, but we will do some analysis, so don't go anywhere. We'll see what actually happened there. Yes, as I said, guys, this is a very naughty rocket. First it does the slide and now it did the spin, and I don't know what it will do next time. And don't worry, it's the learning curve every rocket company experiences. What happened, Mark? I'll tell you. We are actually
And it looks like we've lost video of the upper stage and standing by for more information.
yes, we have lost the video because the second stage was spinning just after the deployment, and as I there are certain things that happened during that point of time, which I will discuss also, which I noticed during my first viewing only, that there was some issue in the separation only. I must say that. We'll see. I'll discuss, so don't worry, don't go anywhere. Right now things are not looking great. We are waiting for the official confirmation though, although the second stage did the spin. It is a naughty rocket. Yes, I would actually term this rocket as a naughty rocket. This is nickname for this one. What should be the nickname? It's like the youngest child of all the rockets, so it's the naughtiest one. First it did the slide and now it did the spin. Have you ever seen a stage tumble like that and survive? Nope. It is actually, the problem is it could have survived, but I think it's not reignitable, and once it is ignited, it can't be stopped. So if it is spinning, that means there is some issue with there was some issue with the separation. There could be some issue with the separation. We'll get to see that from the video feed, which we will discuss. But this is not recovering. If you have played KSP, have you ever recovered from a spin? March 2028. That should have answered your question, right? Recovery from a spin is very, very hard, and I haven't seen any rocket recover from a spin. First step of any spin like this is to cut off the engine and then see what needs to be done. If there is some RCS thrusters or something like that, we need to use those to control the rocket and then reignite the engine, but that does not happen at all. It will rarely happen because most of the time it is trying to get into the orbit and it does not have that time margin to do those corrections. So everything has to happen in quick succession, and this was something which which was actually good to see. I must say that. After the stage separation, there was a bizarre. Okay, so guys, yes, if you are just joining in, let me just tell you what has happened. We had a successful liftoff. Nothing was wrong with that. Successful liftoff, successful MaxQ attained, and then the MECO also attained. That was everything till that point was successful. And after that, at the time of separation and ignition of the second stage, we had some issues, and just after the ignition of the upper stage started spinning, and that is a sign of the naughty rocket. As I said, this is one of those rockets. First it did the spin, now first it did the slide, now it did the spin. Looks like the stage did not separate before the engine ignited, Blue Traveler. I thought the stage actually separated. The stage separation was premature. I saw that. We'll go through the video again. So and do the analysis. So just stay with me. I'm just waiting for the official confirmation. Then we'll do our thing. And yes, guys, on this channel we do these kind of things. We are
Thanks for standing by.
okay.
We're still waiting for more information on the LV0008 mission. Right now you're seeing
And
a video
guys,
pad at Cape Canaveral.
this is the fault of Carolina. She said this is the LV0006 launch vehicle, and that launch, that rocket heard that. I am assuming, and now we saw some of those things of LV0006 happening here. It's like a elder brother for LV0006. It did the slide, and now LV0008 did the spin. So yes, guys, and don't worry. This is, see, in these rocket companies, this is a norm. You will have some unsuccessful launches, but the main purpose of a launch is to acquire data, but not, yes, it is also to make it successful, but the secondary mission is always to acquire that data, that juicy data, because with that you will be able to improve the systems. And now whatever they have acquired with the data and everything that they have acquired, that would improve their systems, and hopefully we would see the next launch to be a successful one. So I think, yes, I can feel the stocks to have some stock to do that stock dance. I called that right, but don't worry, guys. Astra will try again. This is always their policy, and they have already attained the orbit, okay, successful orbit, and there are so hundreds and thousands of unknown variables for a rocket launch, because every rocket is unique in its own sense. The fundamental principles remain the same, but the design and engineering is unique for every rocket. So and the space is hard. Space is real hard. So yes, don't worry, they will try again, and just stick for the failure analysis. That's what we do on this channel, guys. We do the live streams, we do the science streams also. If there is anything happening in space, interesting thing happening in space, the landing on moon, like that. I covered the Chinese Mars mission landing on, basically China's Mars mission landing, NASA's Mars mission landing, with when nothing was there. China's Mars mission landing, nothing was there, but I was somehow able to do the stream. So this is what we do, and if you want to support me, you can do that by becoming a member of this channel or a Patreon. Super chat is always enabled for one-time funding. And let's hope we can have the official confirmation first of all, and then we'll see what actually went wrong. The engine ignited and the stage was not separated. We'll see, guys. We'll see, Blues Traveler. I am not seeing. I will see that separation event, second stage ignition event with you all. So I'm not seeing it right now. I'm just waiting for those official confirmation to happen. Once we have that, then we can actually guess also. Then we can actually pinpoint on to some things that would have happened. Failed at separation. That's what I also saw during my first watch. That's what I felt during the separation only. I thought, this is not going right.
And thank you for standing by with us. Unfortunately, we heard that an issue has been experienced during flight that prevented the delivery of our customer payloads to orbit today. we are deeply sorry to our customers, NASA, the University of Alabama, the University of New Mexico, and the University of California, Berkeley. More information will be provided as we complete a data review, and you can follow along for updates on Twitter at Astra, as well as on our website, astra.com.
Yeah, everyone, thank you for tuning in for today's live coverage, and thank you to Astra for partnering with NASA Spaceflight and allowing us to broadcast this launch to everybody. And again, stay tuned for further updates from Astra and from NASA Spaceflight. But thank you all so much for watching, and stay tuned for more information. But we'll see you later. Thanks, everybody.
Okay, so now we had the official confirmation, and don't worry, Astra, I know you will make it the next time, so not worried about that. Just a second. We'll switch over to the live stream, and we'll see from the launch itself, right? And try to figure. We know something has happened during the separation, but let's try to gather all the data which we can by rewatching the launch once again. And at that, and the point of separation, we know something has happened, but again, let's see if something has happened during the first stage ignition or things like that. Let's see. Okay, so we'll see the launch again, and at the point of separation, we'll do our analysis. Okay, so see, just be with me, and if you have anything to say, please type in the chat. I'll try to listen in and do. Right now, let's do the failure analysis.
8, 7, 6, 5, 4, 3, 2, 0.
This thing, many people thought that during this event of liftoff, it did not actually lift off for the first few seconds. This happens with every rocket launch because the rocket actually waits for the engines to come to full thrust, and when they come to full thrust, then the hold down clamps which are holding down the rocket, they release, and then the rocket lifts off. So this was perfectly nominal.
LV0008 has launched and is on its way to space. You can
like
follow the
everything
flight
was
milestones
going great
on the
right
left
now.
side of your screen, as well as the velocity and altitude of the vehicle.
We'll have a look
next
at the velocity and altitude also, because why not, right? Okay, wait a second, YouTube is messing up with me. Just a second. Not right. Well, let me just reload it once.
Flight milestones on the left side of your screen, as well as the velocity and altitude of the vehicle. Our next objective is MaxQ.
11 meter per second, 1 kilometer. Altitude velocity is looking nominal right now. The engine plumes are looking great. So everything is going great for the first stage. At least we can say that till now. Velocity, the velocity is increasing very slowly. I must say that. I don't know whether it is increasing slowly or that updation rate is slow. We'll have to wait and see about that, because during the liftoff, it felt like it had a good TWR. So, nevertheless, it attained that velocity which it had to attain, 246 meter per second. Now it has achieved Mach 1. It is achieving Mach 1 at 300 plus meters per second, and yeah, there you go. Mach 1 achieved. Speed of sound exceeded. 12 kilometers achieved. Right now things are looking great, and this is not a problem. This is perfectly nominal. This is like those things, guys, which happen during the for the aircrafts also. At this altitude, you see a trail going from the aircrafts to right. So this is that, and this is perfectly nominal. And thank you so much, John, for that 20 to help you build your own less naughty rocket. Great stream. Thank you so much, John. really appreciate it, and thank you so very much. I must say that only right now, because this really helped me to do those things again and again. So okay, let's get back to it. 565 meters per second, 19 kilometers. This is nominal, nothing wrong in here.
Should have passed through MaxQ.
Okay, should have
All
passed through
systems on the vehicle
MaxQ.
are nominal.
Third
We are
looking
tracking it
nominal.
downrange.
Okay, velocity is increasing
We'll be
at a
looking for MECO
good
or
rate.
main engine cutoff at T plus 2 minutes and 50 seconds.
34, 36 velocity and altitude. Yep, right now it's a good thrust. What that's what we can say in velocity and altitude. Although we can't, I'll have to plot a literal graph with to actually pinpoint if there was some issue or something like that. But right now it's the way it is accelerating and the way it is increasing the velocity and altitude. Seems like everything is looking fine.
Clear skies have provided a great view of LV 0008 so far.
Yes, velocity is actually this time it is out of fuel, right? So the TWR is maximum and hence the velocity increase is, you can see, is increasing very rapidly. 69 kilometers achieved. 73, 87, 82. So according to US, it is above the Kármán line as of now. According to US.
Flight MECO option sent.
Okay, this thing is we'll have to hear because this was an awkward call out. We don't hear this thing in other streams, but again she said this was normal, which means they were just activating the FTS for the upper stage. We'll have to wait and see. Let's hear it again.
Flight MECO option sent.
Copy.
FTS confirms option detected.
Safety can't confirm.
That call out of the option means that the system will safely be able to ignite the upper stage after
MECO.
Okay, so that call out was just a normal call out. That means the system will be able to perfectly ignite the second stage. Okay, that means ignition was not a problem. Okay, so this is the view of the second stage, the upper stage, and this is the view of the fairing, I guess, or we'll have to wait and see. This is the view of the upper stage, and now see what actually happens. Right now I'll have to actually see the velocity also.
Means that the system will safely be able to ignite the
Right now it is holding at 4341 kilometers and it is already above Kármán line as per international standards also. So drag is not an issue here.
upper stage after
MECO.
our stage separation.
MECO confirmed. Okay, this something happened here. Okay, I guess there was like a premature separation because you did you see that certain jerk?
The system
Notice
will
that
safely
jerk
be able
there.
to ignite the upper stage after
MECO.
our stage separation.
After MECO this jerk happened, but let me just tell you, this jerk could just mean that the engines have stopped thrusting. Okay, so the MECO means obviously the first stage has stopped thrusting, so that the jerk which you saw was because of that. I am assuming that is the case, so this is not a thing. So I actually observed this jerk, but now I can say that jerk was because of the MECO which happened. So it was sudden cut off from the thrust, so that's why a jerk, but that should not have happened.
And that was MECO or main engine cutoff.
Okay, now this I think this is what I saw. This meant that you can see the upper stage actually colliding with the fairing. Nothing is seen here, but here we can see this was normal. This felt like nominal.
MECO or main engine cutoff.
But this was the footage which I saw and thought there was a premature separation, and I think there is a premature separation. The let me just see the timeline also, whether the separation has to happen first or the fairing separation, means the stage separation has to happen first or the fairing separation, because that would give us some clue whether what actually had to happen. If the fairing separation had to happen, which means the fairing actually did not separate it, and then when the engine ignited, it literally exploded the fairing and it went out of that. If that is the case, that would be very exciting, I must say that. What is the case here? Timeline. Yeah, there you go. The upper stage ignition in 3. Okay. Yes, the fairing separation, upper stage fairing separation was to happen first, guys. I think that has happened, and that is the case I am seeing here. We'll see if the fairing separation actually happened here or not. But this was not a premature separation. It was to happen at 2 minutes. Yep. The fairing should have already separated. Because the fairing separation was to happen at 2:55. Let me just see first of all when we heard the call out for MECO, and according to that we'll be able to.
Safety can't confirm.
That call out of the option means that the system will safely be able to ignite the upper stage after
MECO.
our.
Okay, it actually happened at 3:02, and after 5 seconds the fairing was to separate. Actually the MECO was scheduled at 2:50, but actually happened at 3:02.
Stage separation, and that was MECO or main engine cutoff.
Then the fairing separation should have happened at this point of time. Means 5 seconds afterwards the fairing separation was to happen. So now which the thing the oh, have they literally messed up the staging here? Dude, that would be a KSP kind of a thing. Scott Manley always says check your staging. Did they literally staged the rocket before separating the fairing? That would have that would be very exciting, cool also. Check your staging. Yes, it felt like the staging is messed up here. Okay. It was supposed, the people are saying there is a late MECO. Late MECO is not always a problem. Sometimes rockets take some times. This has happened in SpaceX Falcon 9 also. So late MECO is not a problem, but staging in the not in order. Have they hired Jeb? I think Jeb was there, right? Okay, anyways, let's just see once again what happened.
Our stage separation, and that
MECO
was
happened.
MECO or main engine cutoff.
Oops.
Separation, and that was MECO or main engine cutoff.
And there you had the stage separation. It felt like the stage separation literally bumped into the fairing. Then after 5 seconds the stage was to ignite, which means 3:13 you would see the action actually happening. There you go. Literally, dude, it actually happened. It literally exploded out of the fairings, which means when the engine ignited, it exploded the fairing. Fairing did not separate. I can say that now. Fairing did not separate, and we can actually see the explosion also here. You can see the bits and pieces around here. This is all that because of that. Whoa, dude. Someone messed up the staging.
That was.
And then this spin. Okay, this footage, this view was of the rocket. Cool.
Fairing separation and stage separation.
Then people were actually. Yeah, I feel
and
bad.
You can see that the upper stage ether engine
running.
has lit.
Was running, but it was not. And the pieces which you are seeing is because it could be of the fairing as well as these satellites. Satellites would have recovered also. Then also. So here you guys. see, this is the problem if you have the second stage inside a fairing. So this is one of those variables which was unknown to the people, but now you know that it's not a good design to have a fairing inside the second stage, because this can happen. If the fairing was like Falcon 9, right, wherein it was supposed to separate first and then the stage separation was to happen, but again it didn't happen, and the stage separation happened first and then the fairing separation, or something like that, then the mission may have survived, but not in this case. We can literally see the bits and pieces going around here, and this has ignited because obviously I think there was not any problem with the second stage, but yeah, I think they messed up the staging. You can see those bits and pieces from the first stage camera of those. I think this is of those fairings only.
Opening F.
Maybe it could be ice also, but ice does not glow like this. I have seen many launches. So
V200A, opening FV300A.
and they did not actually you can see have not activated the FTS now. Then we lost the footage. Okay, we did not actually see the velocity and altitude time. Let me just revert back once again, and now we'll see the velocity and altitude to see what is happening and what should have happened.
And that was MECO, or main engine cutoff.
Phase separation actually happened before. Fairing did not separate, or you can say that, but at the point, you know, this stage separation felt like it is stage separation. Maybe it's because you know, but the stage separation was supposed to happen after the fairing separation. No man, stage separation happened first, then it just went out of the just see the
And that was MECO, or main
velocity
engine cutoff.
4315 meter per second, 434 now. Altitude is increasing. That is supposed to happen, you know, the rocket actually attains certain apoapse, so it will, if it is not thrusting also, then also it will coast to that apoapse, which is the highest point in the orbit. So the altitude increasing does not means the rocket was performing fine. The good parameter is the velocity, and right now it was 431. It is decreasing, which means it was not thrusting. So yeah, we'll see now what actually happened. 304, 4288, then it ignited. 4291,
fairing separation and stage separation.
4277.
And you can see that the upper stage
Ether
ether
is
engine
running.
has lit.
Ether is running. We heard the call out too. So I think there was not any problem with the ether engine. And now it started increasing the velocity, but obviously it was spinning out of control. So whatever velocity it was adding, it was also cancelling.
Opening
So you can see
200A,
velocity is decreasing now. Altitude is still increasing because obviously it is at that suborbital trajectory. And then we are still getting the telemetry 4147, 4136, still decreasing. The altitude is increasing.
Opening OV202.
But the velocity is decreasing, which is not a good sign when the engine is thrusting, which so that obviously means that yeah. And then the last reading was 4102, 4491 and 225. So yeah, that's what the last reading was. Okay. And that happened. Let me just see it for one more time. Do you have any more details? This thing bouncing to the fairing was very weird for me. Either the computer detected that the fairing have separated, and that's why it it was preparing for stage separation, and hence I don't know how those stage separation mechanism is in the Astra rocket, but it was maybe just preparing for stage separation and hence creating some gaps, or I don't know, maybe just guessing that, but the fairing was supposed to separate. That did not happen. It literally bumped inside the fairing, and our when it bumped
Was
inside
MECO
the
or
fairing
band
here,
cut off?
this point, rest in peace, CubeSats. Okay, that was is actually a big rest in peace here. Then it really exploded out of the rocket. You can literally see the pieces and bits and pieces. Yes, we did not miss anything. It bumped into the fairing, and then you see that footage also went out
That
of.
was
Yep, that has happened. Whoa. So guys, if you are just joining in, let me just tell you the thing which you are seeing on your screen is the result of the Astra's launch, and I would literally blame it on Carolina's bad juju, as Tori Bruno always say. You don't remember those failed launches during a rocket launch. He always say that you don't remember that those failed launches during a launch rocket launch, because that's a bad juju. And that happened. She literally called LV0008, which was this rocket, as LV0006, which was that slidey rocket with that slide maneuver. Yep, there you go. Okay, so what has happened? Some rotational inertia mr square. That's not the case here. Mr square is not a case. You have to literally derive it, because John, here you need to take those small masses and to derive the rotational inertia, because I would say dmr square and then integration, right? The stage is not completely spherical. Mr square is of what I don't remember right now. Self of disc or a circle. I don't. Anyways, something moved. Yep, I think it happened quite right. Yes, Rain, you were right. The separation did not happen as it was supposed to do. So Eric says, so where's the debris tracking towards? So there is a thing called FTS in all rockets, which is flight termination system. And there is that, let me just pull that thing. If get that graphic in which they showed the trajectory of this rocket, because in that graphic you can actually see the safe side and what. Yeah, there you go.
away from.
So this is this this blue margin, this blue line is what is supposed to do. This is the error margin, in which if it is inside this blue area, that means it is going as per the plan. Okay, and the launch would be successful. And this red area is what FAA has given to Astra. Now during the after the separation, when it started tumbling, if it obviously it went out of this blue area, so that is not a thing. But if it went outside this red area, it is going to happen. If it is going to happen, which engineers at Astra would have seen, then they immediately turn on the FTS system, which is the flight termination system. This has happened during the Electron launch also, when the Electron launch failed. During the something similar happened for the Electron launch also, when the second stage had some issue, and it also did a slide maneuver and then it started spinning, or it also did some similar. And then they triggered the FTS because obviously it was going out of this range. The rocket must have sent, there are two types of FTS, from the mission control or from the rocket itself. And the rocket itself senses that it is going out of range, because obviously the immediate knower of the orientation and the place of the rocket is rocket itself. And if it senses that its trajectory is changing and going out of bounds, then it automatically turn on that FTS system. So yeah, that must have answered your question, Eric. Okay, so else MECO was late. Actually, MECO could have can be late. That could happen because maybe the engine was not running at full thrust. It's like, engines are made to run not only at 100% thrust but 110 or 120% also. That is actually their thrust. So sometimes when engines are running, they run which the nominal I say the nominal range of it running is at 110%. Like for Delta 4 Heavy, the nominal full thrust is 120%. And when the rocket engines come to 120% throttle, then the hold down clamps are released and the rocket lifts off. So if the rocket was running at 100% throttle and not 110, then the MECO could happen late. So that is not the problem, because I have seen that happening in SpaceX rocket launches also, and they always become successful after these certain late callouts. Yes, as Scott Manley always says, check your staging, and it felt like the staging was in wrong order. Who planned it? Jeb must be there, right? Designing the rockets. Kirandhava says it gonna crash on Earth. Yes, it is. And don't worry, wherever it is going to crash, actually the flight termination system would have taken care of the crash. It would have blown it up into pieces. So if it is blown up into pieces, most of the debris will burn up in the atmosphere itself. And talking about the first stage will crash, or should I say splash down into the ocean, which is not habited by anyone, so that is not a problem. Okay. I hate to be a programmer. Actually, this yes, this could be a mechanical fault or a software fault, right? Mechanical fault could be like the the computer called for the fairing separation, but fairing did not separate at all. So mechanical failure there. And the fairing separation issue is has happened before also. I remember there was one ISRO's PSLV launch wherein the fairing did not separate, and there was one Chinese launch also wherein the fairing did not separate. So this fairing separation issue, when the fairing does not separate, is actually very common. And it's a very, people think it's a very trivial thing that fairing separation did not happen, but yes, sometimes that happen. They don't separate. This is a mechanical thing. Fairing separation is a mechanical thing. There are some certain pins or springs out there, as you, if I say it in layman terms, springs out there which fires. The fairing separates. If that spring does not fire, obviously the fairing will not separate. So yes. And stage could have started spinning because its angular momentum changed when fairing or parts of payload ejected in different direction. Actually, why it started spinning is still, I would say, would depend on various vectors, because it would actually depend on how the fairing exploded. I think the fairing has actually exploded. Let me just see this thing again in slow motion. Okay, we'll see this thing again in slow motion this
Flight
time.
MECO option sent. Safety can't confirm.
That call out of the option means that the system will safely be able to
Okay, let's just see. Jerk of MECO.
And that
I hope that was the jerk of MECO.
or main engine cut off.
Then we'll see that bump. There you go. Was a serious bump. And now you would see it trying to explode or what. It actually felt like it exploded, or what, it separated at that point of time. What it felt like. Well, obviously the weak point is the separation point, right? So if it has exploded also, the breaking point is that separation point only, where the two fairing halves are attached. So yep, if it has exploded, the first point of can say the first point of, what should I say, breakage would be that separation of. So yep, that has happened. It literally just bumped into the fairing and exploded them and just went out of the stage. There you can see that. And this thing which you are seeing now, that the plume with certain cosmic waves or something like that. Cosmic energy could be seen here. If I just crop this image out here, it would feel like it's a certain galaxy or something like that. It is because there are certain pieces which are floating, and after it is coming into interaction with this plume particles from the engine, they are glowing. And here we can actually see, or maybe it could just be a camera glare, but I haven't seen any camera glare like this. It's such unevenness. Could be camera glare, I don't know. Maybe it's just a camera glare or something, fog or something like that. It feels like it is. But
That was
again, now you can actually see the stage spinning this time,
fairing
going in this direction.
and stage.
Okay, now you can actually see the second stage. The brightness is changing. Plume brightness is changing because it is spinning. So one time it is facing the camera, the engine facing the camera. The other time it is not, and then this effect. This is certainly some bits thing which is flowing now, which is glowing also.
See that the upper stage ether engine has lit.
Then was the last stage which we got. We can literally see that spinning. Actually, in slow motion we can see some more details. Whoa, this was one hell of a launch, man. Manly tweeted stage assisted fairing separation. as you said. Thanks Nishant for pointing that out. We'll check out on Twitter also if there is some official things, because we tend to find things about rockets on Twitter also. Stephen says S1 pushed into S2, S2 fired, blasting S1 back. You can see S2 motor fire and it's spinning off in the left pick view from the S2 on the right pick. S1 pushed into S2. Yes, that happened. No, S1 pushed into S2. I don't think so. That has happened. Or maybe, that pairing did not separate. That has happened for sure. Okay. That bumping into the first fairing is a different issue. It could have it actually happened after the MECO. Okay, so maybe MECO did not happen. There was some certain residual thrust, as they always say, but that is not the case with liquid engine. That is the case with the solid engine. Maybe it was the second, there was some MECO did not happen properly, and then that's why it bumped in the fairing. That could be one of the possibility, but I don't think it would have happened. Stocks have gone down to all-time 3.26. It's very hard to be a public rocket company. I must give Astra that thing of being so bold, of going out in public. Did this have a auto FTS, and can anyone confirm? Jack says. Jack, actually we did not know, we did not hear the mission call outs as of yet, but I think when this event happened, when the rocket spin out of control, FTS system is activated. And says, I just tuned in, I see that it went off, but it is going to be destroyed. The status on my app said the rocket is a failure. Yes, status on your app is correct. The rocket has failed, and it has been destroyed. I can say that. When it is tumbling and spinning, then it is not adding any velocity. Whatever velocity is adding in one direction, it is cancelling in other direction because it is spinning. You can imagine that. Like when the rocket is, let's visualize it like this. Rocket is right now pointing up, okay, and it has started its engine, and now it's started spinning. What has happened? It first of all, it pointed in upward direction, started thrusting in upward direction, but now since it is spinning, it will point its engine in it will point, I would say it will point itself in the downward direction, which will cause the engine in the upward direction. That would cause the thrust to go down rather up. So whatever thrust it gained by going up and pointing in the upward direction at first, has lost that because of that spin. I hope I can make myself and you can visualize that, and that's why during a spin the rocket does not gain velocity. And if you are a KSP player, you know that pain. It's very, very hard to take control of a spinning rocket. We're going to cover the SpaceX booster splash into the moon wildflower. Nope, that is a everyday event, I would say. So I won't always. And other thing is that I won't be having anything to say about that. So guys, if you feel whatever information I'm giving is worthy enough for a like and a subscribe, please do that. And for more such streams and more such analysis, please try to become a member if you can, and support me in Patreon. It would really help me. And super chats are always enabled for fun time. Could be mechanical or program error. Yep. Michael says, very interesting perspective. Thank you for your expert narration. I am no expert in this rocketry, but I do know some things. So I try to connect some dots, and hopefully and most of the time it is correct. So yeah, thank you for appreciation. Separation by pyrotechnic. Yes, YTL, that's what is used in most of the rockets for separation of the fairing. I did not want to use this word pyrotechnic because I know many of my viewers are not very much into those technical terms here. Bolt popped but didn't separate. Right side left orange line. Did it? I did not notice that, Jay. Are you saying the bolt pop but the right side left? For these, for the bump. Yes, something changed here. Yup. Yes. Thanks for JJ. I did not. Uh, uh, I actually missed that part. Yes, you can see this thing. If this was a bolt or this, actually this is a second stage camera here, okay, and this was a bolt, or is this just a, the late response of this second stage going forward? I don't think so that bolt has popped, but just the camera perspective has changed. Since the second stage has moved forward, so the camera has also moved forward. I think that has happened. Or maybe the bolt popped. See this. Obviously it has moved forward, and okay, yeah, this, wait a sec, it has moved backwards. This is a close-up view, right? This part right now in the normal configuration, at proper configuration, launch configuration, is here, which is in the zoomed view. The next frame, that part is here. Yes, I think so. The bolt has popped. Bolt has popped. That's why there's some gap created. So the bolt did pop, but the pyrotechnic system had a failure. So that means the stage separation was, what should I say? The fairing separation was commanded by the rocket. It actually did not happen. And then there was no check actually there established in the programming. So this is one thing which Astra team must have learned, that they need to ensure that there is one check also in their programming, that literally fairing has popped or not. Then they should fire the second stage. If it has not popped or separated, then they should work on separating the fairing, because here the bolt did pop, but the fairing did not separate. But obviously the second stage ignited. That means there was no check whether the fairing has actually separated or not. So this is one thing which Astra would need to update on their programs. Oh, it's are hard. Lens, it's the lens all messed up on the gun. That rocket basically melted everything when it inside. Yes, Ben. Yes. Actually, the that lighting up should have happened after the separation when there was some gap. So yes, Ben, that is also a good perspective. That camera glare was because of that melting, might have happened because of that plume. While at the second stage, I have just answered Starbase that question of yours. I think they did not have the check whether in the programming they were going like fairing separation. After that, just do this. First of all, the fairing separation in the programming, it is like, I know programming, so that's why I'm saying it might be like first do the fairing separation, done. Okay, then there was no check, like if the fairing has separated, then do this, else do that. This check was not there, so this if else statement needs to be there. If the fairing has separated, then obviously light the second stage, else do something to separate the fairing. Something like that. So yeah. What happened, Arpit? We just saw the Xtalk. We are doing the failure analysis. That's why I'm live. Now we can move on to our Twitter feed. Let's see whether how's Twitter going on. We experienced an issue in today's plan. Deeply sorry, we were not able to deliver our payloads. I am with the team looking at data and will provide more info as soon. And this is Chris Kemp, the CEO of Astra. And this is the official statement coming in from Aurora doing its thing. This is also happening because of the geomagnetic storm. If you live in the polar regions, you might be seeing such. Astra says we experienced an issue during today's flight that resulted in the payloads not being delivered to the orbit. We are deeply sorry to our customers and the small satellites team. More information added in the due time. No worries. Yes, but mainly the fairing did not open before the second stage was released, and that the second stage picked up rotation when the release happened. Yep. Or maybe just the second stage picked up rotation because the cube. Actually, what is there? The CubeSats are above the second stage, right? The CubeSats are not like a pointy structure where it is literally at the center or point, hitting at the center of the fairing. So when that bump happened, the CubeSats were not fully central at that point of time, and after the bump, when the engine ignited, since the CubeSats were not at center, it picked up rotation. If this explosion or going through the fairing was at the center, all these things happened at the center, right? Then the spinning would not have happened, hopefully. But since the CubeSats were there and they were obviously stacked, keeping in mind that it would not bump into the fairing, so obviously that center thing was not kept in mind. Oh yeah, this has happened. And guys, Astra has lost a rocket, but today we are going to see this beauty come to life. Hopefully we will be seeing some updates on Starship, and as you can see, Starship has been stacked for the presentation, and I don't know what's the time, but not the first time rocket has suffered fairing release problems. As I said, fairing release is a very common thing. It has happened with the PSLV rocket of ISRO's. I remember there was one case with the China's rocket too. I don't know which rocket is this one. Fairing separation issue is a very common one. Rocket failing pain scale. Starship prototype, no worries. Astra Rocket, Falcon 9, Atlas 5, SLS. Okay, this is a good meme. This is a good name. Yes, Astra and Starship does not hit, too much. But if SLS will failed, whoa, that would be very painful. You can light engines inside your fairing as a treat. Yes, that has. I think what we see is one half of the fairing remains attached, and we see light coming in the other side. Cast the way out like bat out of hell. As I said, it literally exploded the fairing. Rocket assisted fairing separation. There you go. Sprenker says so. Section 2 is tumbling out of control and will be destroyed before re-entering atmosphere. Yes, that should be happening. The FTS systems are there for this reason only, that if something goes wrong, the flight termination system can. Those flight termination system is nothing but bombs planted onto the rocket, and if something goes wrong, that those bombs explode and make sure that these the rocket actually goes. This rocket actually becomes one single rocket becomes many parts. Those bombs ensure that. I don't, why you didn't hear the FTS system to function at this point of time only. The reason is because they were very high above the atmosphere right now. The reading was like 196 or 200 kilometers, right? And if they would have started the FTS system, triggered the FTS system, that would have mean there would be a debris cloud in the orbit, which nobody would like. So obviously this is right now in the suborbital trajectory, but that explosion would cause some parts to be ejected into the orbit. That would not be a good sign. So maybe they are waiting for it to come down a bit into the atmosphere and then activating the FTS system. That's why we didn't hear. Okay, sometimes Flight Club has bugs. Okay, Flight Club, bug was there. There was some software glitch or a mechanical glitch. We'll have to wait and see. And the other part of the world, we did have a OneWeb launch, and it was fully successful, as you can see. Just 2 hours before this launch. The cameras are 106. Yeah. Yep. This has happened. Staging memes will now surface the internet about this staging and all. So we can go on and on and on looking at this and finding out problems. So I have now done the initial analysis of the rocket. Knock knock, who is there? Fairing who does not move. Okay. So the next update is that we might see the Elon Musk Starship update today only. We still haven't heard from him whether we are getting a presentation today. We might not get today, then we'll have to wait and see. What about the stocks? Dude. Okay, it 359, then it went up, and then okay, wow. 6% down. Okay, I guess we can. Oh, I was supposed to, 30% down. Yes, it is. You know what? I was supposed to turn on the members only chat, but I thought I would do this thing from now on, that after the launch happens, I would turn on the members only chat. But today was not that day, because obviously there are things to discuss, and the rocket has failed and had to go away. Was 26% down. 26% down today. 1.38 USD down. Guys, hit that like button if you haven't done already, and hit that subscribe button too. So I think that's would be it for from my side. If you have anything else, you can ask me, and do follow me on Twitter at RocketGyan is my Twitter handle. I will post the updates from Astra there, and okay, that's it. And please consider becoming a member. Would really help me. The rocket went up, the stock went down. Thank you so much, John. Really appreciate it. Is it destroyed yet? And yes, it must have. We don't have the official confirmation, but I am telling you, it has been destroyed. So don't worry about it. Either by natural causes or by FTS. Was at like 4,000 kilometers per hour, like 4.1 kilometers per second. At that speed, when you're falling through the atmosphere, that to an upper part of the atmosphere, you encounter severe heating that would melt everything down for this rocket. Yeah. As I said, guys, so let me just summarize the stream. We anticipated a good launch today, okay, but and we waited for some time. I explained you everything that you needed to know. As you know, I always do that. Everything that you need to launch. We had a beautiful liftoff. Can't take away that we had a beautiful liftoff of the Astra rocket. The 5 Delphin engines were ignited without any problem. Everything was fine. They attained a good MaxQ, and they attained a good MECO also. Let's hope MECO also was trained properly. And after MECO, problems happened. What problem happened is in front of you. The second stage bumped into the fairing. The fairing did not open, and then there was a fairing assisted separation. Sorry, the second stage assisted fairing separation, which simply means the second stage literally exploded out of the fairing, and it then just went out of the control. It started spinning, tumbling, and lost the payloads. So this has happened, and as I said, Astra is a very naughty rocket, as I said already. And Carolina did a bad juju by saying LB0006 during just like 1 minute from the launch. She said this an LB0006. You know what happened to the LB0006? Bad juju pinned, and there you go. Mr. Tori Bruno, if you follow him, he always say that don't you ever think about failed rockets during the time of the bad juju. I think he was right. So guys, don't worry about it. I know and I believe in Astra. They have recovered from these things in the past also, when they had failed launch. So how many failed launches already this time? Second, but 3 launches. They only had like one successful flight, LB0006, wherein they entered the orbit. It was their 8th flight, so they failed 7 times. I think they would have acquired a good amount of data now, and finally they'll be able to improve their systems and make sure that this does not happen again. So thank you all for tuning in, guys. I appreciate your presence here, and I hope I was able to make you feel better about the stream. I was able to, impart some knowledge onto you, and I hope I was good host today. Thank you all for tuning in. I would join you again with the next launch, which is, I think, the PSLV launch, which is happening. And when the ISRO launches, I become very excited, and there will be some animations also. So do come and join me on the Valentine's Day, 14th of Feb, for ISRO launching its rocket, PSLV rocket being launched at that point of time, and hopefully we would see good liftoff there. So until then, this is Piyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.